Hello, once more. Welcome back to the cellar that is Leopard Street. Filming this on Sunday. Video went up on Saturday. I wasn't really expecting to actually. As I said, I made this. It doesn't work. Well, it does work. And then I broke it. Today, I'm going to make another one that works. The editor's decision is final on this. It is going to work. It is going to be slightly better than this because it has some LEDs on it and I like blinking lights. Positive thinking. Let's get to the desk and we'll have a look. Okay, the desk. Now, those of you who've seen the electronics relay video will recognise this little circuit here. A relay, I've not drawn this side of it yet, but what we're going to have, there's two contacts here, and then there's two contacts over here. Do this. Normally this switch connects to, I've drawn this a bit badly, but anyway, normally it connects to these ones, and then when you activate coils it connects to those ones. So what we're going to have is this comes over here like this, and that goes to the track. I've then got that wire comes up here, that comes up here, that is the DCC input, and then in a slightly different colour just to make it a little bit easier to see, not brown because that's not going to stand out brilliantly over the red purple. That gets connected to that one, and that gets connected to that one. Reversing circuit, coil energizers, polarity changes really. It's all that's going to do. 5 volts ground. The input could be 3.5, it could be 5 volts. It's going to be 5 in this case because it's going to be an Arduino driving it. Little transistor down there, which I've got in a bag over here. Transistors. 2N2222 transistors. Very basic, very simple, general purpose transistors. They're not brilliant if you want to make an amplifier, but to be honest, for something like this, they're perfect. I'm using them because I've got a bag of them. 1K resistor on the input, just to limit the current coming into this thing, because otherwise you'll be shorting the input straight to ground. 100K that sits here. Purpose of that, assume that's not connected to anything. The base is now connected to ground through this 100K resistor. The transistor is now off. Very definitely off. Without that, the input is floating, and you might pick up enough voltage there that this will start to turn on. Don't really want that. I want to make sure that if there's nothing connected to this, this relay stays off. Flyback diode as usual, so when this switches off, if this has been on, the energy stored in the coil has got somewhere to go. It just discharges through the coil's resistance, easy. And then a little indicator LED. And that's that. So what I need to do now is build it. Now, the previous version of this, that didn't, well, I say it didn't work, it did work, is this. This has got the DCC inputs wired incorrectly. This is taking the outputs from the, it was a bit of a mess, and I also screwed it up. So I'm going to get rid of that. That's all going over there out of the way. I've now got this version. And the main difference here is I've flipped the transistors around. They used to use the tracks under the relay, they now don't. It means I've got space for the LEDs. So, that is what I'm going to be attempting to build today. And we shall see how we go. I've got myself a drink, because such things are needed. Find somewhere to put that where I can get hold of it without it being too much in the way. Over there will do. And I've got the board. So, this is strip board. If you're not familiar with strip board, congratulations, this is strip board. It's just copper tracks running in one direction. So you put components on this side, you solder it on this side. The first thing I'm going to do is clean it, because this stuff always needs a bit of cleaning. So I'm just going to move that out of the way and just do this. This is steel wool, and by doing this I just make it a little bit easier to solder to. That's all this is going to do. This isn't a lesson I learnt from the one that didn't work. This is just something I do when I'm working with stripboard. I do this for the board controllers, and I do this for here. The idea of this video, this is just showing, this is going to be in two parts. This is the electronics side. This is going to be basically how do you take that circuit diagram and make it. There's going to be another video on installing this. So the first thing I need to do, I've got these grey bits here. This is where the mounting screws are going to go. So I go in 2 and 2, take this little tool, which is basically just a drill bit mounted into a handle. It's designed for cutting the tracks, but it'll do this quite nicely. And I'm just drilling holes through. Instead of breaking the track, I'm just continuing until it goes all the way through. These boards they're like a papery stuff, laminated. So they're fairly easy to cut. Full disclaimer on this, I did try to do this as a printed circuit board. Slight problem. After 5 attempts, the toner transfer method to get the artwork onto the copper clad board just wasn't working. I suspect the chemical I'm using, which is an acetone and ethanol mix, I suspect the acetone is a bit elderly, is all I'll say on that one. Right. That's that. Later on I'm going to come back and cut a few more tracks on that. But that's that. Now the first thing I want to do is fit the relays. In theory I should be doing resistors first, because resistors are... no, they all fell off. The resistors are the smaller components, and then the diodes and so on and so forth. In practice I'm going to do the relays first, because their positioning dictates where everything else goes. So that's what the board looks like. So I take one of these, and that's the size that is, which is why, yeah. Literally, this is just a grid I drew in a spreadsheet and brought it out here. So that goes, is that one? 1, 2, 3, 4, 5, 6. So no, it's not that one. It goes over another one to there. And then 1, 2, 3, 4, 5, 6. Goes up another one to there. So that's where that needs to live. I'm going to turn my soldering iron on, because if I don't, I'm not going to get very far with this. Right, there is then 7 holes, and I'm going to make sure I get these the right way round. So that's 3, 4, 5, 6, 7 into there, and then another 7 holes up here. So 3, 4, 5, 6, 7. That puts that there, or it would if that pin would go through. There we are. Now that actually leaves me... I need some more... ideally I want a little bit more space up here. This bit's a bit full. So what I'm actually going to do... you see I've got a little bit of space at the bottom, so I'm actually going to move them all one slot down. You could obviously use a slightly bigger piece of strip board for this. I'm using these because I've got a lot of strip board in this size. So they're there. I now need to solder those. Once they're soldered, I can do a bit more work with this. So turn that over, like so. Bring my magnifier down slightly and light so I can see what I'm doing, because this is a little bit awkward to see. Soldering. I'm not the world's leading expert on soldering, quite frankly. I can sort of get by at it, but I'm not brilliant. Anybody who's seen me solder anything will confirm this. And the scary thing is I used to do this sort of stuff for a living, but there we go. That was many, many years ago when I was an electronics technician working on an assembly line in Derby. The job was testing and repairing things that had been built by other people. So the question is now, can I get solder to melt onto this soldering iron? A little bit. Right. So touch that onto there. That big blob of solder is not going to work. So that is just going to get cut off. So touch that there, heat up. And what you're trying to do is get the solder to flow all around the pin on the component, like so. Preferably without going everywhere else, which is this was the problem I had on the first version, is I got solder bridged between one track and the next in such a way I couldn't get rid of it, which is a dead short electrically and basically rendered the whole thing rather useless at that point, which is slightly annoying because it was near the end when I'd done most of the effort. So yeah, if you are doing soldering like this, just take your time. This is quite a big solder tip for doing this with. I've actually changed it. I was using quite a small one. This bigger tip is not ideal, but what it's got thermal mass. And what do I mean by that? There's a lot of metal on the end of this tip that gets heated up. And you may think, well, why on earth would you want that? Well, with the heat in the tip, the moment it touches something cold, it starts to cool down, funnily enough. So the moment it touches this copper board here, it's cooling. Well, I don't really want it to cool, because I need it to be hot enough to get that where I need it to be. I need it to be hot enough to melt the solder. So I've then got to hold it onto the thing for longer while it heats back up again. Whereas if I use this slightly larger wedge-shaped tip, this holds a lot more heat, so it won't cool down as much as it hits the board. Now, copper conducts heat rather nicely. Heat and electricity, in fact. Let's get a bit more into that. It's not soldered on properly, so we shall just go into there. I think I do actually need some new solder tips. I'll have to order some this week, because I've got a few, but they're all getting a bit long in the tooth. And like everything else, they're consumable items. They do run out. If you do get a soldering iron, you will have to change the tip at some point. But yeah, what I'm trying to do here, get this warm enough that the solder flows freely. A little bit of solder on the soldering iron helps. Just helps with it conducting. And ideally you don't want to block any of the adjacent holes while you're doing this, because if you do, you can't poke out through them from the other side. This is another lesson I picked up actually from the other one. Originally I was using the 1602 dropper wire on these boards where I'm carrying DCC. I'm not doing that on this one. I'm going to be using single core hookup wire. This is not ideal, but I'll be using single core hookup wire because it works much nicer with this sort of board. It fits through the holes, and away we go. Here we are. Hopefully you can see what I'm doing. Yeah, get these on here. In practice, a lot of this is probably going to get this video footage is going to get sped up and given a voiceover. There we go. Sound of thunder upstairs. Right. And that's the relays fitted. So what I now need to do is, at the moment, this leg and this leg are connected by the copper strip. I don't want that. So what I need to do is come in here and just twist this just enough to break the copper. Don't want to go through the board, because if I go through the board, I'm weakening it. So I can do that on all three relays. I need to be careful not to break the adjacent tracks, because I'm actually using the tracks that go through here as conductors. So if I take this out here, now what you need to do, I don't know if you can see this one here. Let me just see if I can get this to zoom in. a little bit. If you look at this one, it looks broke, but when you're looking closely you can see there's a sliver of copper along the side. If I leave that, when I connect this, that'll short circuit. So I need to cut through it just a little bit more. Like that. Right, that is the relays done. So on here, this side of the board is the output stage. Yeah, just get that right. And this side is the input stage. I'm going to do the input stage first, because then I can test it. I don't need the outputs connected to anything to test this. So the first thing is some diodes. Now I'm using 1N4148 diodes, which are these from Bright Components. I get these on eBay. Bright Components is not somebody I'm affiliated with in any way, shape or form, but I have been a customer of theirs for a number of years. So I need 3 of these little diodes. And these are little diodes, but they'll do for this. They'll do this purpose quite happily.
Now at this point in time, editing me is going to take over, because this build sequence, the video is about an hour, and then there's about another 40 odd minutes worth of other stuff. So what I'm going to do is I'm going to speed this up, and I'm going to just talk about what we're doing. So here we go.
Right, so here we are. We're not switched on just yet, so what I'm going to do first off, I have to put these two wires here are my power wires, power and ground. So that one is ground. So, open these up a bit. Ground into that one. So, power goes into this one here, maybe. There we are. Right. So I should now be able to power this on, which I can do by powering the layout up. So the Arduino is powered. I have around here somewhere a small purple piece of wire, and what I need to be able to do with this should work. Right, tilt the board a little bit, I touch that, and you can see a red light comes on and I can hear it clicking. So move on to the next one, which with my arms it makes it a bit easier. I'm trying to, yeah. So that touches there. See the red light comes on, and again I can hear the relay clicking. Final one. See the red light flashing. That tells me, turn it all off now, the logic side of this is done. So that so far works. What I'm now going to do is put the switch side on, which is the DCC side. So back to the desk. That test is well worth doing, because if that doesn't work, there's no point building the other side. So back to the desk.
Yeah, so here we are back at the desk. So just labelling the connectors up, and the next thing is the output stage. So that's where the DCC input's going to go. It's going to use two of the tracks. Provides a nice common little bus. This is effectively three separate reversing circuits. They all have a common input feed. These here are the crossover wires, so the normally open of one side connects to the normally closed of the other, and vice versa. Basically then when the relay energizes, it does the reversing. So that's what these little 6 wires are going to do. They go in over the top of the relays. If this was a printed circuit board, there'd be tracks underneath it, but they're not. Single core hookup wire, it's not really ideal for this sort of thing, but it works nicely with these boards. It can handle the voltages and the current required here, and the length is short enough the extra resistance doesn't really matter. So in they go. There's those 2 wires for each of the relays. They can then get nicely trimmed. After that, we need to put in the feed wires between the 2 DCC bus rails and the common, sorry, not the common connectors, one side of the relay. The brown wire to the normally open and the blue wire to the normally closed. It doesn't really matter which way around you do it, but it's helpful to be consistent. So what I'm doing here, I'm using legs from resistors that I cut off earlier, sort of bending them into a little U shape. It forms a little staple that goes between 2 adjacent tracks. You could do this with a solder bridge on the bottom. It's easier to do it with a little piece of wire on the top. It's also slightly clearer what you're doing if you have a problem with it and you come to look at it later. Yeah, so they get built in with a pair of tweezers, solder them on the back. Again, it's a fairly straightforward procedure. There's no real circuit as such on this side of the board. This is now really just connecting the relay switches, getting ready to connect them to some terminal rails. The final bits to connect will be the actual terminal blocks. So we will have 3 of them on the output side, 1 for each of the reversing circuits. These will be going parallel to the tracks instead of perpendicular to them, which is perhaps a tad unusual, but they go in as a whole miss a hole, so you can drill the middle one out. And what it means is it's quite simple then to say I want to put a connection in to either side of them. So that's basically what I'm doing here. Is I'll fit these. Yeah, aware it's not brilliantly centered in the screen. And then there comes some extra wires, and these connect to the two common terminals. So the top one connects to the two common terminals of the top relay, middle one, yeah, you get the idea. Once they're in, there are then some more tracks to cut to fully isolate this side of the circuit, keep the switches isolated from each other. And the top connector goes in as well, which, yeah, all things considered, that sort of works. A little bit of a continuity test here. This is making sure there are no short circuits on the DCC bus. Needless to say, there were to start with because I hadn't drilled out all the other holes on the bottom. So yeah, we tested the first one, then we put the connectors in for the rest, and the wires in for the rest, and that's more or less it for building the board. This is just a simple little video, really, on how you get from a circuit diagram to a thing. In this case, the thing is a triple sort of reversing circuit. Could be anything. I mean, the board controllers, they're made in pretty much the same way. It's here's a circuit diagram. I'm now going to take it into this. So that's that. Okay, here now. To do is switch everything on again. And we've seen the static test, which is with no power, what connects to what. So that pin connects to there. So what I now need to do is connect relay 1 to 5 volts, and that is now switched, so the light is on. Hope you can see the light is on. So that. So on the unpowered relay it connects to that terminal, on the powered relay it connects up there. That relay is switching. So, test the next one. But not that. That one works. Switch this one. That one works. Right. Disconnect that. I can switch that off. I can turn my multimeter off. So, this little blighter, hello, this little blighter now works. This can switch, it'll take a DCC input on this terminal block. It's got 3 outputs, 1, 2, 3. These will go to track 1, track 2, track 3, where the little shunting loco is currently sitting. So yes, track 1, track 2, track 3 behind these wagons. Track 1 has got sensors. Track 1, all I've got to do is reprogram the Arduino, give it an output feed into here, and I can drive trains through this inner loop. And while this is a JST connector, it's obviously, this is designed to sit on its own circuit board. For now, it can be driven that way with just one of these little bits of wire. But, so that's the conclusion of this video. So this has shown the initial screw up and this one. This is a fully functional board. It's not as capable as it should be because I've had to use thinner wires. Now, if this was a printed circuit board, the DCC tracks would be much thicker. They were 1mm tracks as opposed to 0.4 for all the others when I was doing the thing to start with. And if you think, well, that's not enough, you can then run solder along the top of all of those tracks as well to really beef up the current carrying capability of them. This is little hookup wire. These locos are using at most an amp at 15 volts. this wire can cope with that quite happily. Its resistance, like I say, is a little bit higher, but it's like a 2 centimetre length of it, 3 centimetre for this top piece. Done. Anyway, that's it for this video. I'm going to do some 3D printing. I'm going to grab some lunch, and then I'm going to come back down. I'm going to do Tuesday's video, which will be coming out before this one, which is going to show the rest of it. So, as usual, likes, comments, shares, subscriptions, and all that sort of stuff are more than welcome. And I'll catch you on the next one. Thank you very much, and goodbye.